Good afternoon. Thank you for joining the Northern Virginia Technology Council and Virginia Tech for our inaugural Data Science Speaker Series event. Please welcome Tom Wotecki, Chairman of the Data Science Speaker Series and Director of Analytics and Applied Statistics Master's Program, and the Director of the Academy of Data Science at Virginia Tech.
Well, good afternoon, everyone. I'm delighted to welcome you to today's Data Science Speaker Series event, featuring the Chief Innovation Officer for SingleStore, Oliver Schabenberger. Oliver's presentation will be followed by a panel of data science experts. It was great to see so many of you in the social lounge networking before the program started. I hope to see you there again after the program. I'll be lurking in the lounge. Hope to meet you. This series is a partnership between NVTC and Virginia Tech. NVTC is the trade association representing the Capital Region's tech community. NVTC unites, educates, and advocates for our members to advance a thriving tech ecosystem where we live and work. Virginia Tech, my alma mater, is the land-grant university of the Commonwealth with a growing presence in the Northern Virginia area, including our innovation campus in Arlington. The series will showcase the impact that data science is having on business, how government policy is being made, and how the application of data science is changing our daily lives as citizens and consumers. The series is made possible by our sponsors, Virginia Tech, in partnership with NVTC, and George Mason University, our silver sponsor. Thank you for your support, and a special thank you to the NVTC business partners and academic partners. Their support enables NVTC to provide content and programming year-long, and they are Booz Allen Hamilton, CIT, the Center for Innovative Technology, the Consumer Technology Association, Dell Tech, Dominion Energy, George Mason University, Innova, KPMG, Maximus, Microsoft, Noblus, Northrop Grumman, PenFed Credit Union, Pillsbury, PNC, SAIC, Venable, Verizon, Virginia Tech, the policy advisor Hunton Andrews Kurth, and the PR and marketing advisor, the Merit Group. Thank you all for your support. Now it's my privilege and honor to introduce our keynote speaker, Oliver Schabenberger. Oliver is the Chief Innovation Officer at SingleStore, where he is instrumental in connecting the company's business execution with its technology vision and direction. He is a former academician and seasoned technology executive with more than 20 years global experience in data management, advanced analytics, and AI. Oliver formerly served as the Chief Operating Officer and Chief Technology Officer of SAS, where he led the design, development, and go-to-market effort of massively scalable analytic tools and solutions, and helped organizations become more data-driven. He is a fellow of the American Statistical Association. He's co-authored 3 books and earned his PhD and MS degrees from Virginia Tech. Please welcome Oliver Schabenberger. Over to you, Oliver.
Thank you, Tom. Thank you, Tom. And now we'll say now the immortal words of, I hope, can you see my screen? And let's hope for the best that you can. Well, thank you very much for the opportunity to present today. I'm honored to be chosen as the inaugural speaker in the Data Science Speaker Series and to contribute to this collaboration of the Northern Virginia Technology Council and my alma mater, Virginia Tech. While what I'm sharing today are thoughts and views on data science, statistics, machine learning, artificial intelligence, digital transformation, and so on. Thoughts and views that are informed by my own experiences as a statistician, as a software developer, as a leader of innovation teams, and of businesses for over 20 years. My first introduction to the term data science was in the early 2000s. And I had heard that the data scientist is the sexiest job of the 21st century. Well, my background is in statistics, but I immediately thought I might be a data scientist. Today, many jobs advertised or described as data science fall more into the categories of, call it data engineering, data architecting, business intelligence analysis, and so forth. Whenever something is impactful and it takes off, we tend to see that type of halo effect. Artificial intelligence is certainly in that category. In 2001, William Cleveland, the professor of statistics and computer science, published a very ambitious plan to enlarge the field of statistics. He called it data science. The new discipline would be a merger of knowledge bases, bringing data-driven thinking to computer science and knowledge about computing to statisticians. Over the next few years, though, rather than a convergence of the two disciplines of computer science and statistics, we saw a little bit more of a divergence, actually. And the term data science initially permeated my discipline, statistics, only slowly, at least. That was my perception. Big data was on the rise. And it was not looked upon friendly by the statistics community at the time. And it felt like an overemphasis on data collection, lacking rigor about how the data were collected. The idea that more data is necessarily better data, and that just given sufficient compute power, you can wrangle answers from data is kind of frowned upon, and rightfully so. But there was no stopping this approach, the computer science approach to data. Computer science was actually changing its focus from looking at computation, looking at data. At the same time, this period for many organizations marked their entry into digital transformation. How do I become more data-driven? We had to deal with new data sources, behavioral data, unstructured data, click streams, images, audio and video were already on the all of a sudden on the rise, and those sorts of data were asking for a different approach to number crunching. Digital native companies like Google, Amazon, Facebook started to build business on these data sources, and it created FOMO, fear of missing out, in the more traditional business world. Data all of a sudden had value. And the new currency that was on the rise, data scientists, they were the rock star fluent in that trend. So when I'm asked what data science in general and machine learning in particular are about, and we are getting back to a convergence of those disciplines and how they inform each other and how we get strength from that diversity, it helps to consider how these disciplines think about data. And the important thing, and I want to say this up front, is that we think about data. Wonderful development in our digitally transforming world, that data becomes a way of life, a way of thinking, and more of us engage with data. As someone mentioned at the beginning of the COVID-19 pandemic, I'm quoting from memory, the number of people who are looking at exponential curves has grown exponentially. So let's look at statistical models first as an example of how we can think about data. In statistics, I was taught that a set of data is a realization of a random process. We call it the data generating mechanism. So there's something happening in the universe that creates data sets, and what I'm observing happens to be a realization of that. And in order to understand the data, we build models, statistical models. George Box is often quoted as saying, quote, "All models are wrong, some are useful." And That quote is frequently misinterpreted as, well, you cannot trust any model, scientific or statistical. In fact, at the beginning of the COVID-19 pandemic, you would hear all models are wrong, some are useful frequently in the media. I remember an incident or a case around March 2020. The pandemic was racing through the country, racing through the world, and predictions of the number of cases everywhere. I was just preparing for a media event when a new forecast came out from the Institute for Health Metrics and Evaluation, IHME, at the University of Washington. They forecast 80,000 deaths due to COVID-19 in the United States. It was a shocking prediction at the time, higher than any of the previous estimates. Well, today's forecast for the number of deaths from the same organization is around 618 deaths. So, was the model from last March wrong? Yes, but it was still useful. Based on the best information and best assumptions at the time, it prepared us that this will be worse than what we thought yesterday. It was directionally correct, and that was enough to inform public health measures. So the models we develop are not copies of the real world. They are just abstractions that allow us to study a phenomenon by focusing on what matters most. A statistical model is an abstraction of a data mechanism. A digital twin of a wind turbine is not a duplicate copy in binary form. It's a digital abstraction through which we can observe the key attributes of the turbine. And once we accept that model as useful, a useful abstraction, it becomes the lens through which we view the world. We test hypotheses, we predict outcomes, we infer the inner workings of the system, and maybe even interact with it. And then I was introduced to machine learning. And it takes a different approach in thinking about data. Rather than asking which process generated the data, they're just as data. And based on the nature of the data, whether it's a binary target or a continuous target, depending on the goals, whether it's a recommendation or to predict something or to classify something, you can choose from many, many different methods to perform the task. So finding that best method for that particular set of data is part of solving the problem with machine learning. So rather than validating a model against any underlying assumptions of a random process, as a statistician would, machine learning validates the approach against the data itself, splitting it into separate sets for training and validation. Now, the important thing here is there's nothing fundamentally wrong with either approach. We know fully well, in many statistical applications, the underlying assumptions of those random processes are often not rigorously checked, and that's not good. We also know that just uncritically automating and searching for patterns in data is also not good. But the disciplines can really learn from each other and build on the respective strengths. So that was a quick view about how we think about data. Now let's consider another very important aspect, how we speak about data, data literacy. There should not be a big surprise that we have different ways of thinking about data and what data mean. We should totally embrace it and from each other. This quote from Leo Bryman in 2001 is very interesting. He said, quote, "Algorithmic modeling in theory and in practice has developed rapidly in fields outside of statistics. If our goal is data to solve problems, then we need to move away from the exclusive dependence on models, data models, and adopt a more diverse set of tools," end quote. So machine learning can benefit from incorporating uncertainty in decisions about data. Modeling can benefit from more computational sophistication in working with large data sets. I have been a hobby musician. And For many years, I played music, and during the pandemic, I also started to record and mix music. And you might wonder, where's Oliver going with this? I learned through that process of playing music, but also recording music, that the musician and the audio engineer have different views about music. They listen differently. So in order to make a great record, you need collaboration and sophistication on both sides. The musician plays instruments, the audio engineer uses analog and digital tools to blend the tracks into a pleasant recording. And the collaboration is facilitated by communicating in the same language, the language of music. Beats per minute, measures, bars, flats and sharps, major and minor chords, and so forth. It's the language of music that both sides understand. I recently read a book by Yuval Noah Harari, his book Sapiens, and in it he introduces the concept of a partial script. For example, mathematics is a partial script. By that he means it allows us to express not all of spoken language, but actually, on the other hand, some things that fall outside of it. And I think music is such a partial script. You can express the love for someone through a piece of music, but it is really difficult to do accounting with music or to do your taxes. Math is great to keep accounts straight, but it's not good for writing poetry. So I argue that in this digitally transforming world, we also need a partial script to increase data literacy, the communication in the language of data and analytics. Warren Buffett said some years ago, accounting is the language of business. I argue that today data is the language of business. We are facing a massive data skills gap. Everyone is talking about being data-driven. 40% of the domain experts, though, admit they are not sure what that really means. Data literacy, the ability to read, understand, analyze, manage, and act on data, it requires being curious about data, learning with and about data, and something that I attach to the ability to argue about data. Terms like causation and correlation, signal and noise, confidence, prediction, forecast, estimate, distribution, data types, probabilities, they are all part of that new vocabulary. Here's a really, really great example about a difference between causation and correlation. I found this in an article in the New England Journal of Medicine, and it got in 2012. It got republished or cited in a Business Insider article in 2014. What you see here is the relationship between the consumption of chocolate per capita and year and the number of Nobel laureates in countries throughout the world expressed on a per 10 million basis. Causation or correlation? Now, if this were a causal relationship, the author of the original paper concludes that you can generate a Nobel laureate by eating an additional about 400 grams of chocolate per person per year. In the United States, that would be about 130,000 tons of chocolate. The author also notes that Sweden appears as an outlier with a number of Nobel laureates. It was 32 in 2012. Exceeded the number expected under the trend, which is about 14, based on their chocolate consumption, by a factor of more than 2. Well, he writes, quote, "One cannot quite escape the notion that either the Nobel Committee in Stockholm has some inherent patriotic bias when assessing the candidates, or perhaps that the Swedes are particularly sensitive to chocolate and even minuscule amounts greatly enhance their cognition." That's arguing about data, causal or correlation. And if it's correlated, if it's causal, does X cause Y, does Y cause X, or are they maybe both the result, that relationship, the trend, the result of underlying shared trends. Now, I also noticed that my home country, Germany, seems to consume a lot of chocolate and not produce a lot of Nobel laureates. So if the correlation is the causation, I would advise to reduce chocolate consumption in Germany and move it closer to the trend. Being curious about data means asking questions. Questions about the origin of data, who collected it and for what purpose? What data really telling us? So if we can argue about the analysis of data in the same way we argue about a piece of music without requiring a degree from Juilliard, then we have become more data literate. Organizations are good at collecting and storing data, but I believe they have not done enough to spread the language of data. And that language barrier between those who speak it fluently and the business users hold domain expertise is an inhibitor. Someone recently told me he does not believe in the concept of a citizen data scientist, that they would not exist for the same reason we do not have citizen neurosurgeons or citizen jet fighter pilots. Well, I hate to burst his bubble. Citizen data scientists do exist. In a data-driven world, almost all of us are citizen data scientists. The definition is a citizen data scientist is a non-data scientist. It is someone who desires to do data science, but is not formally schooled in the ins and outs of the discipline. Her job is not data science, but she uses it to get her job done. She might not know the difference between random forest gradient boosting and support vector machines, but she knows what enterprise data are important, has access to smart tools that allow her to go from data to decision. I like this definition in non-data scientist. I'm a citizen corporate executive. I desire to be an executive, but have no formal training in the ins and outs of the job. But I use tools, management, leadership, finance, marketing to get the job done. And yes, I agree, there are no citizen neurosurgeons or jet fighters. So we do not use jet fighting or neurosurgery to get our jobs done. When COVID-19 hit early last year, I served as the COO and CTO of SAS, a privately held software company. Immediately, our customers reached out to us with questions such as these. Where is the virus now? Where is it going to go next? I need to be situationally aware of what's happening. How do I need to reallocate and redistribute medical supplies? Where do the ICU beds go? Do I need them? How many do I need? I need to optimize the supply chain. What is going to happen? What will happen next? What are the most likely best case and worst case scenarios? It was fascinating to see the role data-driven machine learning played in answering these questions. Or maybe I should say the role it did not play. Machine learning techniques, finding patterns and relationships in data, has not played that big of a role in solving these questions about COVID-19 early on. And with all the hype around artificial intelligence and machine learning, you would have expected a flood of AI solutions to address these issues. Where were they? Modern machine learning techniques are excellent at recognizing patterns. Given enough data, they can learn to match patterns, to predict, to classify. But in the absence of this training, there is not much they can do. At the beginning of the COVID pandemic, there was simply not enough data from which we could learn how to predict and how to make decisions. The flu pandemic of 1918 was not much help. So our approach at SAS to answer those questions had to rely on something else. We went back to epidemiological models known as SEIR, S-E-I-R models. These are compartmental models that capture how an infectious disease moves through a population in stages. Those stages are to be susceptible, to be exposed, to be infected, and to recover. The underlying mathematical model is based on differential equations. And it goes back to my earlier comments around statistical models, scientific models as abstractions. A differential equation is not a useful abstraction to describe your or my individual progress with a disease. We are not differential equations. But at a population level, across hundreds of thousands of individuals, it's an extremely useful abstraction. So SAS worked very closely with the Cleveland Clinic to develop models and scenario analyses that help the clinic make decisions about medical resource optimization. We published those models, made the tools available so other hospitals, counties, states, public health organizations could apply them. And there was a very important learning process here as well. The importance of scenario analysis over prediction. A prediction such as X thousand deaths by midsummer might not be as helpful as being able actually to manipulate the input parameters and the factors that drive these models and to visualize what might happen, to visualize decision envelopes. For example, if compliance with social distancing or mask wearing changes from 45% to 70% over the next 2 months, and the R naught of the virus is lowered by 0.1, how does this affect the best case, worst case, most likely scenarios for hospitalization? That was an approach to CR models that had worked well in the past. So we should not simply throw them out just because there are new approaches that came along. For example, neural networks. There's a lot of strength we can gain from embracing the diversity of methods and techniques. One such technique or methodology, if you will, that has really come to the forefront and has risen in the last decade is artificial intelligence. And I want to spend a few minutes on that topic. Artificial intelligence is the building of computerized systems that make decisions or perform tasks you and I could make. In the last decade, AI has catapulted onto the scene and into our consciousness. 20 years ago, the future of AI was it had no future. But with the availability of mass and compute resources based on cloud computing and specialized hardware, we saw a resurgence of artificial intelligence. Now we had enough computing to train deep networks. And with the advent of big data, we had enough data to train these networks well. And the result was really a step change in the accuracy and performance of these AI models. Successes like deep learning algorithms beating the world's best player in the ancient game of Go, autonomous vehicles driving through Silicon Valley, or computers diagnosing diseases on medical images, they created shockwaves. Articles about super intelligent machines and the end of humankind appeared everywhere. But interestingly, in the next few years, the conversation moderated quite a bit. In 2017, it was all about the machines are coming for us. They will subjugate us Terminator style, the end of humanity. Well, the next year, the machines were coming for our jobs. Not for us, but there will be mass unemployment, and we maybe might need to consider a universal income because we're all going to be out of jobs. 2019, that conversation changed again. No, the machines are not coming for our jobs. They will augment us. Artificial intelligence is here to enrich our jobs and our lives and make us better at what we do. And then last year, it was, oh my God, I need it now. The world is changing. The digital automation is needed. I need AI to lead my organization through this year, through the pandemic. Now, what does artificial intelligence look like to us today? It's not a humanoid robot that acts and learns like a human. The self-driving vehicle is not a normal car with a robot in the driver's seat. This latest iteration of AI is a data processing system. It's data processing embedded in another form of technology. I argue that the real advance of AI is not to create human intelligence. Nobody wants algorithms with consciousness. You do not want the autonomous vehicle to daydream about the Tesla 2 intersections back. The real revolution of AI is to automate processes by using data. Rather than asking an expert to translate her decision logic into machine instructions, like we would do, for example, in tax preparation software. This data-driven form of AI extracts patterns from data, and given enough of the right data, can achieve really astonishing results. And a really remarkable result, one that might revolutionize the way we think about software and software engineering, is that AI algorithms can be produced based on data alone, rather than a software engineer explicitly programming a system. We could call it implicit programming based on data. The information data imprints the algorithm. So given these extraordinary capabilities, it's worth asking why this form of AI has not yet revolutionized every industry. Well, we've been talking about it now for a good part of a decade. If it just takes compute power and data, why have we not built AI systems that underwrite insurance policies better than actuaries, that argue legal cases better than lawyers, that write literature better than poets, or manage hydrocarbons better than an oil and gas company? Well, truth be told, we have made incredible progress in many of those areas. And the gap between machine and human performance is closing. But the idea that you can replace an incumbent business simply based on data and technology alone is just not playing out. Domain expertise and domain experience are still key ingredients that you cannot replicate by simply training on data. A computer vision algorithm can actually differentiate a benign lesion from skin cancer. But as long as its understanding is based on patterns of pixels rather than medical information, rather than disease, it remains an assistive tool. So let's revisit COVID-19 and our progress in AI and computer vision. As I mentioned earlier, initially we didn't have enough data to really train models, but we were starting to gather data. The use of computer vision in diagnosing and prognosing the disease, especially COVID-19 from lung x-rays or CT scans, was an application that came up very quickly, but initially algorithms performed rather poorly. A number of reasons. The algorithms went through transfer learning. They were actually originally built for different applications, trained to recognize body lesions. They had a hard time with the hazy appearance of COVID in the lung. There was shortage of data, and other issues can cause hazy appearance in areas of increased density in the lung, so that initially they were not that great. These algorithms were not that great as diagnostic tools. But there was a lot of activity since. And the algorithms have improved dramatically. Right now, they can achieve 80 to 90% accuracy, and the area under the curve, the RSC curves between 0.7 and 1, that is solid. That's a lot of progress. So, why are we not using them in practice? Where are they? Why are we using antigen and PCR tests instead? A study published last month in Nature Machine Intelligence, provides some excellent food for thought. This study reviewed all published papers from January through October last year on machine learning models for diagnosis or prognosis of COVID-19 from X-ray or CT images. Over 2,000 Over 2,000 papers were reviewed. And following the initial screen, 62 of those studies were reviewed deeply, systematically. What do you think the result was? And I quote from the paper. None of the models identified are of potential clinical use due to methodological flaws and or underlying biases. Wow, 2,000 studies, not one usable model. But the problem's not the technology, it's the methodology. What are some of the issues? There were problems with the data. Authors did not establish the original data source. There was duplication and quality issues in public data sources. Some data sources were mixed between data from adults and pneumonia data from kids, so that the modeling did not classify or detect COVID as much as classify adults versus children. Data sets were reassembled, redistributed, renamed, repackaged, and recombined, so that oftentimes it was not clear exactly what those data were. Models went through transfer learning. So it was a computer vision model that was trained for a different purpose, that was done, adapted or learned to also detect COVID. It was the image resolution of the original application that dictated the image resolution in transfer learning, rather than the clinical judgment of what should the best resolution be. The images were ground truthed by PCR tests, the best available test, but it also makes it impossible to say whether the models improved on the existing diagnostic procedures. And many of those studies use small data sets with less than 2,000 data points. Data-driven AI systems based on deep learning, they are not good at capturing logic, but they are really good at sensing the natural world. So computer vision for medical image classification is a perfect example. Strength comes from diversity. Not every problem has a good solution in neural networks, although some problems definitely do. We just saw one of them, image classification. But poor methodological execution that keeps us from using this work in practice is simply a self-inflicted wound. AI systems that make us better at what we do can add massive value. And you do not have to reinvent your fundamental business model. Take manufacturing example. Manufacturing medical devices might lead to the rejection of entire batches of products based on a single defective item. If we can use computer vision to identify defects on each individual item, we could save millions. It's transformational to the business, but not a new business model. So should we not expect applications like that to be implemented everywhere by now? Well, unfortunately, the reality of artificial intelligence, machine learning, the reality of data science is different in many organizations. The reality is it's far from being a reality. Data science and AI initiatives that fail to gain traction and are not delivering are quite common. Data science projects fail in many ways. Most actually fail before they ever make it into production. And substantial barriers still exist to adopting a data-driven approach. So how do they fail? How do those projects not materialize? Some fail after they are deployed. Well-intended projects can turn up and have undesirable consequences, things we didn't think of before, side effects or gaps, and we have to shut them down. A good example of an AI model gone bad you might have heard of is Tay, a chatbot or Twitter chatbot. Tay stands for Thinking About You, that Microsoft launched some years ago. It did not take long to start making racist and sexually charged tweets in response to other users. In fact, it took only a few hours after it went live. K started to mimic the deliberately offensive behavior of users who trolled it. Well, Microsoft did not teach the bot what inappropriate and offensive behavior looks like. The assumption was that won't happen. That wasn't the thought. The failure was not to recognize that the internet can be a nasty place. And after only 16 hours, Tay was taken down. But that's not typical for AI projects. In fact, most AI projects do not fail after deployment. They fail by never advancing from the sandbox or the playpen into production. They fail by what we say they are not operationalized. Here are some of the numbers that I've found, and I think they're quite sobering. Gartner states that 60%, more than half, of data analytics projects fail because they were not aligned with the business strategy. One customer told me that the data science team was very proud that they've found a way to predict a customer's age based on how he or she navigates, for example, the website. I said, that's great. We have their date of birth. It was solving a problem that didn't exist. Of test models that are worthy to go into production, less than half ever get deployed. And of those that do, 90% of the models take more than 3 months to implement. That's a long time. Among the barriers to success, the barriers to adoption, organizations talk about are barriers related to the business, barriers related to people, and to data. Lack of stakeholder buy-in often is being mentioned, lack of budget or IT infrastructure. Data science that occurs in isolation from the business. The industry analyst company Forrester reports that over 40% of the companies cite low collaboration between data science and application development teams. There is a bewildering array of tools and point solutions, and enterprise companies are left with integrating all of them, and it turns their IT departments into system integrators. There are questions about ethics, fairness, bias, and transferability of the work. Almost everyone cites lack of talent. I don't know where to find the data scientists and the data engineers and the technical talent to scale these efforts. There's an impact on employee relations. Employees might feel devalued when you automate parts of their jobs. And many organizations struggle with their data strategy. Data continue to be siloed in transactional and operational systems, multiple definition of what a customer or region product is, with lack of integration. And organizations that start with data science, that start with AI, might find that they do not have the data that they need to address the problems they're interested in. So what does it all tell us? It's early days, still early days in AI, and we have not yet realized the benefits of the technology. So if you feel like you're behind, don't worry. Feeling is common. You probably are not as far behind as you think you are. And if you want to prove the value of data and the value of analytics and AI in your organization, choose an application as a core competency of your business. Something that everyone can agree is critical to what you do. So unless you are in the talent acquisition business, starting with a hiring bot is probably not going to lead to success, and not going to convince the rest of your organization about the value of AI and data. And what I have noticed in the last year and a half, is that the definition of success is changing. That data science teams are measured differently. They are measured by business outcome, the value they generate for the business, not by the number of models they generate. Also, that the management of analytic assets scoring algorithms, logic, decision logic, has become really, really critical. So in addition to understanding provenance and performance over time, does a model period, for example, is a model valid for a particular application? Is it ethical? Is it fair? Is it transparent? Is it explainable? What are the potential biases? These questions are becoming increasingly important. Algorithms, no matter how they come about, whether it's decision logic, expert system, AI model, an epidemiological model, whatever. These algorithms are now a source of risk, reputation risk and operational risk that needs to be managed. So where does data science fit into this? The world of analytics is undergoing a number of changes. Machine learning and AI, more important today than they ever were. We can now implicitly program algorithms. There's many more technologies, open source technologies. We're computing both in the cloud and the edge. It is confusing and very disorienting. And all these are happening at the same time. The next phase of analytics is not the great convergence of all these things. The next phase evolves from these forces as a response to the need for scaling and automation. Data scientists report they spend much time working with data, wrangling, preparing, merging data, cleaning data, integrating data, and not enough time on the most valuable part, how to develop, operationalize, and manage the models that drive the business. I believe that the future of analytics is to be hidden in plain sight, to move into systems of intelligence that connect the traditional systems of records and the systems of engagements that talk to your customers and your employees. If we can apply AI to provide a product recommendation, if we can tell you what the best fridge is for your kitchen, then we can use it to recommend table joins and aggregations. Then we can use it for data quality, and we can use it to optimize and automate. The role of the data scientist will not be automated away. It is elevated. It's elevated to be a key enabler of the business. The data scientist is in charge, literally in charge of being the logic, orchestrating and governing it, including managing the ethics and risks of automation. Data are beautiful, but it is through the decisions that we affect the world around us. In our digital world, decisions are increasingly based on data, and analytics is the intermediary. I believe the future of data science is decision science. And the role of the traditional CIO, the Chief Information Officer, will change. It might fade. I checked Netflix. The leadership page on their website does not list the CIO. The role of the Chief Data Officer and the Chief Analytics Officer, they will meld, and they become the true information officers in the organization. Let me close with a glimpse into the future. I believe we're in a fascinating era of technology. Right now, technology is training us. It's training us to consume more technology. Algorithms we encounter when we shop online, when we're on social media, when we sit in front of the TV, they are built to attract and hold our attention. We are spending the energy and brain power of the smartest people in technology to maximize our exposure to ads. Personally, I think, what could we accomplish as a species if that brain power and energy were directed towards other goals? We are training people right now to build technology for us, to help consume it. I call it technology literate people. the database administrator, the data scientist, the IT specialist. Technology is not like gravity or thermodynamics. It's something we invented. We can turn it on, we can turn it off, and we can do it differently. So one way of doing it differently is to turn the relationship around. Today, we develop software for other technologies. Frequently, other software developers that use something, a platform to build an application. Low-code and no-code frameworks are good steps towards democratizing technology. But in a way, they just remove layers from the middle, the database administrator or the IT professional. With the advances in AI, in connectivity, in automation, there's another operating mode that we can possibly focus on. People-literate technology. That's technology that works with us, not just for us. That's technology that knows what we need and does it for us. Think about the role of the computer. The burden to translate intent now moves from the user to the computer. Let me give you an example of what that might look like. You all might have heard or know or use dashboards. Use a dashboard to get relevant information about the business, about your organization, along with possible root causes. And you want information that help you answer what, how, and why questions. So in a world of technology literate people, how does it look like? Database administrators, IT personnel, data scientists, they create those dashboards for us. They have key KPIs on it, metrics, and I monitor the dashboard, sometimes daily, weekly, some monthly, to get a view of how the business is doing. And it's up to me to drill down the reports for a deeper understanding and answering questions and finding root causes. That's what we do today. That's technology literate people using technology. In a world of people literate technology, I'm monitoring the dashboard. Automated processes are monitoring the business for me. And they do this through changes in the data about the business. I am being notified of any changes relevant to me in real time on my devices through data stories that explain and deliver information in a way that is situational, contextual, and applied to me. Here's an example. I might get a notification on my phone that says, conversions of online trials to subscriptions are down by 30% over the last 2 weeks. It is predicted that the end of quarter target will be missed for customer acquisition. The drop in conversions of subscriptions coincides with the update of the trial environment to the latest software release 2 weeks ago. Is that fiction? No, I hope not. And it's up to us to make it happen because we control the technology. Another example that might resonate or might sound familiar, and hopefully when we start traveling again, we necessarily have to experience a flight cancellation, but we get to fly again. So imagine you arrive at the airport, you've booked a flight and a hotel at your destination to find out that your flight's been canceled. In a world of technology literate individuals, we take out our phones, our tablets, whatever tools we use, we get online, talk to either the airline or the travel agency, Expedia, Travelocity, whatever site we use to book the trip, and everybody's doing this at the same time, hoping that they get that we all get rebooked. Now, the airline might do this for us centrally, but we have also a different approach. Imagine we live in a world of people-literate technology. Now, while I'm parking the car, my smartphone connects with the smartphone of all the other passengers on the flight and reroute everybody automatically to the destination. What's the difference? It's that these smart devices created an informal network, a self-directed network to solve a task, schedule travel. None of the passengers need to know about it. The devices don't know each other, except they need to know now they need to solve a problem. And once the task is complete, that informal network dissolves. Science fiction? I hope not. It's up to us to make it happen. Let me close by saying that as data scientists, if you listen to this talk, or data scientist, and you are writing the future of what data-driven technology looks like. Your job, as I see it, is to empower society and make society less dependent on the way you do your job today. To design what you create so that those who are not data scientists can explore and interact and learn from data. And in return, your contribution and your responsibility will be elevated. Elevated to running the business with data. Now that might be the sexiest job of the 21st century. I'm counting on you. Thank you.
All right. And thank you, Oliver, for a great talk. One takeaway for me is the importance of data in data science, particularly in AI applications. And I'll certainly do my part to promote the production of United States Nobel laureates by eating more chocolate. I also loved your comments about the emerging role of the chief data officer or analytics officer. Important comment. Thank you. I'm now pleased to introduce our esteemed panelist, Alan Latimer. I didn't know you fell into the category of estimable, but I'll go with that. So pleased to introduce Alan Latimer. Alan is the VP of Data Science, leading the Data Science Group and Analytics Strategy Socially Determined, a company that's focused on the social determinants of health and their impact on disease outcomes and healthcare utilization patterns. Also introducing Phil Vincennes. He is the Chief Analytics Officer for Intellidyne and leads his team's development of solutions in healthcare, financial management, performance management, robotic process automation, and the Internet of Things. And finally, my colleague, our moderator, is Jennifer Van Meulenkamp. She joined Virginia Tech in the fall of 2016. She is the director of the Statistical Applications and Innovations Group, SAGE, and is an associate professor of statistical practice. SAGE provides collaborative statistical support to researchers within the university, within Virginia Tech, and to outside clients as well. She teaches a collaboration skills course to graduate students and mentors them as they practice statistics as SAGE collaborators and consultants. Jen, over to you. The panel's yours.
All right, fantastic. Well, thank you so much, Oliver, for your insightful talk. And I am excited to kick off this discussion. Certainly, I know that the attendees are anxious to bring some of this thought leadership back to their organizations, whether they're actually practicing data science or they're focusing on training future data scientists, because I see a lot of faculty on this attendee list as well. So I'm going to invite folks to enter questions in the little questions bar on the AirMeet webinar. So please look for that if you have a specific question that you want to ask. But before we get to some of our audience questions, I'm going to kick it off with a question directed to Alan and Phil. So after hearing Oliver's message on from data literate to people literate, the reality and future of data science, we'd kind of like to hear your thoughts. So what would you emphasize from his talk? And what additional thoughts would you offer to complement his talk? Phil, I think you're on mute. The story of 20.
There we go. Okay, we actually did what we said would happen earlier in the backstage. So first, I want to thank Oliver for that great presentation. It was very insightful and thought-provoking. And I think Oliver's right. We as data scientists, engineers, BI developers, whatever your role in the data-related disciplines is, we need to focus on making lives better, easier, and safer. And in my opinion, in order to do it right, it requires integration of many data-related disciplines, not just that of the data scientist. The examples that Oliver shared, the business dashboard and the travel reservation, depend on collaborative solutioning between data and software engineers, data science, business intelligence, and process automation. That's a heavy lift to get it right. Years ago, our analytic practice was centered around data discovery dashboard development as many new data science organizations began. I used a law enforcement analogy to tell a story to potential customers about a 20-year law enforcement investigator that could use our dashboards to explore and test their hunches, and hunches that existed based on 20 years of doing criminal background investigations and subconscious storing all of those patterns and connections and relationships without realizing it. And I tell prospective clients they could use our dashboard to easily drill into data and test out their hunch or hypothesis and discover that their hunch was correct and take whatever action was necessary. This was tough back then. But by today's standards and listening into Oliver's address, two things are wrong with this picture. It struck me as odd that we don't model that investigator's hunches into predictive algorithms to bubble those anomalies to the top of the list. And it also bothered me that we didn't automate that next action, that next step, which was typically opening a case in a case management system. So 2 years ago, our teams began integrating BI, AI, and process automation into our solutions that we're building for government clients. Convergence of technology intended to operationalize analytics, just as Oliver was mentioning, by weaving it into the fabric of our customers' day-to-day business operations. And so this aligns perfectly with what Oliver said, and I loved his phrase, analytics hidden in plain sight. I think that's when that occurs, that's when you know you've hit the ball out of the park. I also agree with Oliver that the purpose of dashboards will change. I don't think they'll die, but they'll cease to exist as the decision tool. And they'll simply serve as a monitoring capability to check in on the health of your AI, automated processes. My teams are doing that right now, building dashboards that monitor ROI and health of intelligent RPA bots that we've deployed in enterprises. And to that point, earlier this month, Gartner released, I think it was on April the 5th of this month, a paper on this very topic that we're discussing today. And they entitled it The Convergence of Analytics, Business Intelligence, Data Science, and AI. And I believe that this is a movement that is exactly what Oliver is describing, just using a different set of terminology. And I think it's the biggest first towards achieving that people-literate technology that he refers to.
Thank you, Phil. So I'm going to flip it over to Alan here to give his comments.
Yeah, thanks so much, Oliver. I really enjoyed the talk. And actually, there were a few points that struck me. The first was that models aren't copies of the world. They're not copies of the real world. That doesn't mean, like you said, it doesn't mean that they're bad. And we're often able to leverage the models we have to understand the environment while not replicating it. And so I think that's very important for us looking at social determinants of health. We want to understand what the inequity is. I can't necessarily pinpoint exactly the hungry person on the street or the person that's in financial distress, but I can understand a community of people in ways that start to allow me to help those individuals to get better health care. I love the idea of partial scripts. I also read that book. What a great book, Sapiens. I would recommend it to anybody. And this thought that data science is a partial script where we each can play a role in that we can understand the vocabulary of data science that's most applicable to us. And I think it's also important for us to understand that as data scientists and as practitioners in this field, it's incumbent upon us to help educate people about the power of data science, to help put the guardrails up to say these are things that are good and bad and ways that you can think about the models to help people become literate. I think we should view ourselves as teachers of an emerging science. I think that embracing diversity, we hear that all over the world, but I love the way you said embracing the diversity of technologies. There are 100 different ways to do something. We should look at all of those ways as they start to inform each other. I love the idea right now that big strides are being made in certain verticals because scientists from other businesses and other areas have now come into those spaces. right now with healthcare, if we only looked at the world through a healthcare lens, we would see the same problem we've seen for 30 or 40 years. It looks the same to us because that's what we're used to. But as we bring people in from looking at homeland security, terrorist threat models, that's very similar to understanding what the conditions look like on the ground. If bringing in data scientists and engineers that come from technology and QA processes, how can we bring all these disparate resources and this diversity of thought to bear on problems? And that's the exciting thing, because I think data science can be a partial script that we can all latch onto while bringing this diversity of thought and experience and technology. And finally, I have to put my plug. This is my plug to everybody. Domain expertise is key. It cannot be replaced. I tell people that work for me, you cannot call yourself a data scientist until you get some domain expertise. You have to understand what we're modeling. Without understanding what you're modeling, you're apt to predict, early stage birth or neonatal pregnancies, where you have these children born into the neonatal intensive care unit. You're liable to predict those based on social security number. And that's just a plain not understanding what the domain is and not being able to apply it. So I think those are the things I really took from the talk. And I see so much applicability to what we're doing in our business. And so I really appreciated those thoughts.
All right. Well, fantastic.
Thank you very much. I did not say dashboards are dead. I gave the idea was dashboards are incredibly useful right now. It's a technology we use, but let's think about what could be beyond that. What's on the next hill, right? The technologies we use, they were often invented and fit for purpose for a certain way of doing something, and I give myself the freedom to think ahead. When these technologies converge, what is the art of the possible then, right? And I think, Phil, you're absolutely right. The convergence of things that we thought of in silos, there's business intelligence, there's analytics, there's AI. Well, it's all coming together. And our form of AI today is really data-driven, and it's modeling. It is taking a set of data and crafting a model to fit to it, right? Training a neural network is fitting a model to data. So we're using the same processes and the same kind of crunch. We just call it different things. And so it's also useful as we develop this partial script element that the different disciplines understand what the terminology is and when we speak about the same things and different things. I was brought up in the world of dependent and independent variables. Predicting was scoring. Inference was something different, right? But it's a different language, and we just need to come to terms of what we mean by different things, and that will remove a lot of barriers. Alan, to your point about domain expertise, that is so important, and I think it's worth restating that when artificial intelligence really took off around 2010, when algorithms for the first time beat a human interpreter in classifying objects and images in the ImageNet classification. We thought, just use data, just train big enough models, and you can pretty much accomplish everything. You could accomplish a lot, an awful lot that we couldn't do 20 years ago. But unless you have domain that provides boundaries and the checks, it's very difficult to keep that centered and keep that in the heart, right? A recent study I saw about the question, and we're probably going to get to this, about bias and ethics. Should a particular model that predicts kidney function be adjusted for race? Who decides on that? What is the evidence by which we make or do not make those adjustments? Unless the domain experts are in the room, how would you know? Could we just leave that answer to try to get it from the data? I believe we need that domain. And also what we found is, as you bring in domain, you need for massive data actually is reduced, because the right combination of data and expertise can be key. And so not every organization is able to draw on these massive amounts of data like the digital natives. And so you think, oh, well, then I cannot play a role in this modern space. No, you can't. Right? You don't just need data, you need data and expertise, and that domain expertise can make up for what others might find in massive amounts of data, or actually be more valuable.
I'd kind of like to build upon that idea of domain expertise and flip it a little bit. Thinking about this idea of citizen data scientists, and as we go from the domain experts gaining data science expertise, certainly the case that Oliver cited related to the COVID-19 image analysis classification and diagnosis, there were clinical flaws and underlying biases. How do we train our citizen data scientists to think critically about data science? And how do we know when we've done it? Who wants to take that on?
Nobody. We're throwing it back at you. No.
Thanks.
I'm
trying.
Yeah. There are a couple of things you talked about there. The first thing I think we need to understand is while we'd love people to be everything, they often are not. We find ourselves looking for, it's back to I think you made a statement about how one of the complaints is I can't find people to be data scientists. There's a lack of resources. And I think maybe we're looking for unicorns where we should be looking for teams. Of people to help, domain experts in the room, science, programmers and coders in the room that understand the algorithms, mathematicians and statisticians in the room that understand how to get through that data. I think part of the way that we help with decision bias and model bias is in having a diversity of people and technologies attacking the problem simultaneously. How do you train a citizen data scientist? How do I take the person who's interpreting the model? How do I train them what's good and bad? I think one of the danger zones we're in right now is that running any kind of machine learning model has become so easy that anybody can do it. And so we often confuse data science with someone who can run something in scikit-learn, which is not, they shouldn't be equivalent. To me, I think we need to have real mathematicians, statisticians, computer scientists, and domain experts in the room to set up the guardrails of any model that we decide to use. And that the people that are using that or consuming that information need to clearly understand what those guardrails are and why they've been put in place. And I think, to me, I see that fall down most often when there is a breakdown in communication between teams in an organization. So when the data scientists are not talking to the engineers and not talking to the domain experts, that's when you start to see these problems crop up. So that's where I see we could help dig into that.
I also get a little concerned. I'm a big proponent of doing things easier. And I have seen a lot of the tools that are out there now. I won't name them by name, but some of them are data prep tools and very, very visual environment where you can drag and drop and create workflows. But on the flip side of that, they also have tabs that will allow you to drop down and drag data science related object around and create and create workflows that involve AI and so those individuals that may not understand something like random forest and when you should use it and when not, you might end up inadvertently creating bias or working against bad data. I just think that there needs to be some more data literacy around AI as well for citizen data scientists. I think that it's a potential problem because it's being made easier and easier to do these things.
Yeah, easy is not necessarily bad, but there's a difference between automation and autonomy. Just because something is automated doesn't mean you take your eye off the ball and you let it run and and don't interfere with it. So we have to ask the question: where in the loop, in, on, and out of the loop, is the human, and where is the domain expert, to make sure that if a process is automated, we intervene at the right places and have checkpoints in place. But if the automation tools have only 3 entry points, learn, predict, and deploy, right? Then it's very difficult to really understand what's going on in there. And you kind of, okay, I'm going to hit deploy, and then I hope for the best. That's not a good model. But when you insert then the human in the loop, you need to do it in a way that understands the knowledge base and the situation and the context. So somebody may not know if random forest is the right tool for that particular data and that task. But if a random forest is used, how is that information then being surfaced so somebody can make a correction? And so that's what we need. That's what we need to think of. Otherwise, we're going to create. I mean, imagine just citizen data scientists is just one aspect of it. There's going to be citizen app developers, low code, no code. They can put together, and cloud computing enables that actually, because the building blocks are now much bigger. Very quickly, you can put together a powerful app. And imagine you run an organization and you create like 5 apps a day. How do you manage? How do you govern that? How do you figure out what should be put in front of the customer and what shouldn't, and what are the risks associated with this? So that's all stuff we have to figure out.
Yeah.
Well, it's kind of like if you're doing
that reminds me of. Oh, I'm sorry. Go ahead now.
I was just going to say, it reminds me of tax software now. 20 years ago, you had to go to a CPA and get your taxes done. You're now able to go get your taxes done, but there's a lot of guardrails in that, right? It doesn't let you do whatever you want. It puts guardrails up. And so maybe that's part of the technology we have to push is how do we make these, how do we help people make these decisions better in the education of using those tools? And once you empower people to use them, how do you make sure that they're guardrail so that to protect them from themselves, so to speak? I'm sorry, Phil.
When Oliver was speaking about the no code, low code, my mind jumped back to the early SharePoint days that I think we all lived through, and we still are. But it was so easy to stand up a workspace that everybody was doing it, and the next thing you know, you have this cancerous propagation of ungoverned workspaces and sites popping up all over the place. And I can't tell you how many SharePoint consolidation efforts I've lived through simply because the guardrails weren't up, the templates weren't in place. There was no governance. And so I think, we can see the same type of thing happening as these things become easier, and we have to try to get ahead of it, I think. I'm not trying to discourage it. I love the example. Aware of it.
I love the example of the tax software, because that's a very, very good example of an AI system, computerized, that does a task a human could do. You can go to the CPA, but you can choose to use tax software to do your return. It's not data-driven. It's an expert system. It's the translation of the tax code in machine instructions. That's what it is, right? And so it's a very careful process by which you map that logic into machine instructions. That's different from AI as we discuss it today. As we use today, that's very data-driven. So you could, as an example, take all the tax returns of the last few years, train neural networks on recognizing the financial patterns, and then you put your data in, and it will predict. You should send a check to the IRS and the amount of that, or you should expect a check back from the IRS. Now, everybody in the audience, you have a choice between the AI approach with the neural network or the AI approach with a tax software. Which one do you choose?
I'm doing my own.
But to the point, we have a lot of methods, we have a lot of technology. It's very rich, and we need to choose wisely. And just because something new comes along doesn't completely invalidate what we've done in the past. And I think some years from now, we will look back at maybe this decade, and say, wow, these neural networks are incredibly powerful. They moved us along in a great way. We can now do natural language processing and translation and natural language understanding and computer vision in a way we'd never been able to do. But they also had limits. Oh, and we overcame these limits with ABCD, and here's the next class of models. And so that's how we'll make progress.
All right. Well,
Yeah, it's
thanks
this
all.
continuing. I was just going to say, it's this continuing reimagination of. We were talking dashboards a minute ago, and we said, well, dashboards, are they going to be replaced? Maybe they just continue to evolve to the place where they're, and we find ourselves. You see a radio button all over the place, but nobody knows what the radio, or very few people know what a radio button actually is. That you would punch the radio button to change the station, and you had 5 options, right? That's sort of, to most people, they don't even understand that anymore. And dashboards may, in 10, 15, 20 years, be these tools that allow us to both, that we interface with and that interface with us, and bear little resemblance to the car dashboard they were named after 20 years ago.
Yeah, I think that's right, Alan. We're doing that with in a cybersecurity context where an analyst would look at network vulnerabilities. And they can see the vulnerabilities on the dashboard, but then they can take action on them right there without leaving the dashboard. And so that's where we get this integration between these technologies. And I can see the day where like you said, the dashboard is perhaps it's been reconstituted in a way where you can take action. You can also provide information back to the dashboard. I know that we don't like to have bi-directional information flowing to and from dashboards, but perhaps that's maybe something that we can evolve to.
All right. Well, I want to get to a couple questions that are being asked by our audience members, and kind of continuing on the idea of this domain expertise. We have David Zorn, who's an economist from Magnum Econometrics, and he is asking us if data scientists need domain expertise. What does that tell us about the likelihood of success of machine learning?
I think they're kind of independent. I think that as we continue to evolve models that we have, and they are informed by domain expertise, we will have better and better models. I actually think that because of the need for domain expertise, that enhances the success of machine learning. I don't think you have one without the other, honestly. And so it's, there's this vision somehow that I think Oliver alluded to this early on, that, oh my gosh, machine learning is about replacing all humans and we'll never have to make a decision ever again. I don't think that's really what it is. And I think the most successful machine learning models I see right now are those that were best informed by domain expertise and trained in correct ways and efficient ways, so that they really do a good job of seeing the world quickly for us and interpreting the world quickly for us. And so I do think domain expertise doesn't diminish the success of machine learning, it actually enhances it.
Yeah, I was going to say that I guess when I think about this topic, I think that, at heart, all of us are engineers. We build things, we create solutions. We can't be experts in everything. And if we're going to move the needle toward people smart tech, then I think we need to better understand the perspective of those people that we're trying to help. And so what we're teaching our team now is to take more of a sex kind of a take on a problem set, where we apply customer experience techniques, look at journey mapping. We need to understand the pain, the good, the bad, and the ugly in order for us to put together effective solutions. And that journey will allow us to sort of sit or stand in the shoes of the customers we're trying to help. And then without domain expertise, to start with, I think that helps us get up to speed pretty quickly, and produces a much better solution for that individual, and leads to better adoption, I think, as well. And it includes them in the process.
Maybe the question also asked, does a data scientist need to study the domain? they're working in. Not necessarily, but I think without domain, you don't have a full solution. And so how the data science side communicates with the business and the domain and how they interact and work as a team is really, really important. And where I see problems occur is when the two work in isolation and, I've developed a model for predicting customer churn, and then it turns over here, and then now it's your problem, business, and you do what you need to do. You're more successful if you come from the business problem first. So what is the thing that we want to solve? How is this important to the business? What is the business problem? What's the domain that we're in? And then connect that with the data science, rather than driving it from, I have data, here's look what I can do, and now how does this change the business? But I've found that if you were to imagine you want to develop a model that predicts fraud in any form of transaction, right? That we recorded. So insurance claim fraudulent, or is a credit card transaction legit or fraudulent? Would you really want to develop this just based on data? Or would you want to bring in the people who understand the world of insurance and the world of banking and know what patterns to look for and what not to look for? I would not want to do this without domain. And I think those who combine domain knowledge with the right data-driven approach and bring those together, I think they're going to be very successful.
Agreed. And certainly in my pre-college professor days, I didn't know anything about engine oils or inks or financial models or safety violations or predicting who's going to be engaged with our university. But we've worked in all those areas, and you can see the success of that. And it's really about the willingness, I think, of the data scientists to learn that. So let's continue on with the kind of human element here. So we have a question on the human element, and it says there has to be a willingness to adapt and transform and have confidence in the cost, risk, benefits analysis of data science. For example, convincing people to take the COVID vaccine. So is it the message or the messenger that is maybe creating the lack of willingness to maybe change based on data?
I go back to data literacy. Do we know how to look at data and interpret data? It's kind of interesting to see compare the statistics, for example, about mortality or hospitalization, the likelihood of hospitalization or COVID with what people think those numbers are. And I wonder, why is there this discrepancy? Because we're talking about these numbers all the time. They're kind of front and center. So where is the breakdown? Is it lack of trust that we don't think the numbers are real, that we can trust them, or do we think they do not apply to us? I can't quite figure it out.
Yeah. I think my mother 20 years ago, she wouldn't put her credit card in on a website, but she'd hand it to a 16-year-old waitress in a restaurant, knowing full well that it's much easier for someone to just copy the credit card number in the back of the restaurant than it is to get it off the internet. I think it takes time. I think it takes, first people have to see the technology in action. It has to assimilate into their lives. They have to become used to it. And then I think they accept it. And this is any technology, whether that's computer, the internet, having a cell phone to do everything. I think all of those depend on, first, it gets introduced, there's new adopters, but then there's people that just eventually over time we become used to it. It becomes part of the fabric of our lives. And once that happens, then we begin to trust it. I don't think we're going to be able to just say we suddenly have machine learning models and data science and numerical models, and we've got this new vaccine that uses a technology that never has been used before, and everybody's going to instantly adopt it because the scientists and the people who most vaccines or anything else.
We lost. There you go.
We lost you for a second there, Alan. You're back.
Oh, I'm sorry.
Yeah, we lost the last 5 seconds.
I was just going to say, any of these technologies that emerge, it is as much about for people becoming used to those models and that science as it is trying to, specifically teach a group of people.
I also think there's in the specific instance of COVID vaccine, there is a social media influence, and I wonder what the decay of that sentiment is over time as evidence begins mounting, and people don't die from the use of the vaccine or have complications. So I think it's more complicated. We have to look at some of the social aspects of why people think the way that they do.
Right.
I think that's important.
Okay. So I do want us to get to some of the ethics topics. I'm going to kind of transition into that by just asking about, do you think, and this is a question I'm going to kind of try to paraphrase this here from Michelle Dunn from Morgan Stanley. So do you think the bias of any field, whether it's, say, data science or domain modeling, creates limitations and barriers by limiting education to the exclusion of, say, languages and arts and maybe humanities, in terms of creating a situation where folks are so focused on the analytical side of things versus bringing in the humanities space into AI and machine learning?
Well, I will say this. Oliver showed you his studio. I play music also and have one in my house. I think music and the arts are intertwined with science. I think creativity is at the heart of how we'll be successful. Without creativity, we would just mechanically go forward solving equations without the notion of how we might change the world. I think it's believing that the world could be better and trying to find ways to make it that are critical to success. Now, I realize that sometimes people just focus on we need a technical math STEM education. To anybody that will listen, will tell them I don't think that's right. I think you get the best education when you have a more rounded view of the world.
Definitely agree.
The things we can automate in the future, and that goes to the time I gave about how the conversation around AI changed from all the machines are destroying us to the machines are coming for our jobs. No, they're not coming for our jobs. Was a realization there is a limit of what you can do with any form of automation. And that this form of AI that we're using today is very, as we call it, narrow. It's built to solve very specific tasks that it cannot grow out of. They don't just, the system that knows how to play poker doesn't figure out how to play Go tomorrow. The system that can drive an autonomous vehicle does not know how to turn the lights on in the house. They are very narrowly defined. And so, for one, we control it. And two, the jobs that they can replace are very limited, because unless you can automate all constituent activities of an occupation, the job will not go away. There are very few jobs that are like that. Maybe data processing is one of them. But it also is going to amplify the uniquely human things that we bring to the world, right, and to our work. Empathy and love and compassion and creativity and curiosity. You cannot put that into a machine. Not yet, and I don't think for a long time. And so that is really comforting to me, that there's something that is so uniquely human that will always be better than any other system without that element in it. And we should also work on that and enhance that. One of the things I look for in team members is curiosity and creativity and the ability to solve a problem in or outside a domain that they're comfortable with, and the ability to grow and to learn. And we can call it machine learning all along, but there's not yet a system that can get even close to what we do in this space.
Okay, so I'd like to move on to the ethics part of things, and we have a question that's kind of related to that that's popped up in the chat, and that, you know, this idea of having algorithms and tools and AI kind of hidden in plain sight. What are the privacy issues? What are the ethics issues of that idea?
The idea is not hiding what it does, right? It has to be governed, it has to be auditable, it has to be understood. And that's a core principle of everything we do in automation, in algorithmic automation. It has to be transparent, it has to be explainable, it has to be fair, it has to be private and secure. So I think what we should be doing is making those tenets, design tenets of everything we do, rather than questions we try to answer afterwards, after the technology is in and we try to bolt it on. So if we build this in, we also then start to develop more confidence, and I'm hesitant to use the word trust, because trust is between people. It becomes more responsible and more reliable, and our level of confidence grows with it. It's not about hiding things away and sweeping them under the rug. By hidden in plain sight, it means we have to allow systems to use automation to do some of that work, because there will not be enough data scientists, no matter how hard we work at educating them and training them, to do all this work in this digitally transforming world. There has to be some parts of it to be automated. But as soon as we do that, and they move into the layers where you don't explicitly program and you sling Python code every day to drive something, maybe these models come into being through an automated process themselves. That's when we need the governance and the controls, that we understand at any point in time what it is that's happening. Today, when you buy an electrical device, a lamp, right, you don't think twice about plugging it into the electrical grid, the power grid. If you had doubts, you can turn it over, and you probably see at the bottom or somewhere a sticker of Underwriter Laboratories, and it tells you this is a safe device, you can safely operate it, and plug it in. And you don't worry about plugging it in your home or in a hotel room or some friend's house. We know this is power is a commodity. We need to get to the same place, that we are as comfortable with any form of automation logic or algorithmic logic or process automation, that we know it's safe to be plugged into whatever processes that they work in. And we're not there yet. We're not there yet, but I think we should keep a goal like this in mind and work towards it. Because if you can look at it, you can say, oh, I understand, this is certified by whatever, this has the stamp of approval, now I understand the boundaries of it. For example, you should not plug in that hairdryer while you're in the bathtub, okay? These are some operating conditions. We don't have that yet, but we definitely need to work towards it. So how can I use a model and evaluate it for bias, for how does this perform for minorities, for underrepresented groups, etc. The list is long. And again, having the domain experts being part of that creation of that logic and the certification, if you will go a long way in creating trust in them.
Yeah, I'm also thinking that I think of the word transparency. We overuse transparency in government. However, I think that as AI becomes embedded into the chips and everything that we use, I think that transparency becomes very important. In terms of capturing the metadata about that AI, is there something equivalent to an AI best used by expiration date? When was the last time this AI received training update or IV&V or some form of certification, kind of like your Underwriter Laboratory? I think we need to define and capture the AI metadata in some registry form, that is generalized but also standard, so that we know how to describe AI for those purposes. Perhaps some type of a blockchain-like data provenance. In the DoD and healthcare examples, or some chain, an adversary could easily hack an AI and render our weapon systems useless or cause some other mayhem simply by manipulating the training or learning data so they can actually inject bias. Regular regimes of ongoing real-world testing to prove out the efficacy and establishing those metrics as well up front. So I think that once we have some monitoring and risk mitigation mechanisms that are put into place, then we can slowly begin building trust, but we can never take it for granted.
Yeah, transparency is not achieved by simply handing over code, right? I always say, if you take software you use every day, non-AI software, and if somebody would give you access to every line of this code, it would not be transparent. You could read it all, but you still would not know how the system works. It's really through manipulating the system and working with it that you find out what it's about. And so testing that in a safe way, that's part of being transparent, rather than, let's say, here's a billion parameters of a neural network, or here are a million lines of code that my engineers wrote.
Right. One of the things that I considered when you were talking about AI in plain sight were all the recommender engines that we encounter every day, from Amazon to Netflix. We know that there is some magic going on, quote magic, right? We know it's an algorithm that's been written that will predict what we want to watch or predict what we want to buy. We're aware of it. We're conscious of it. We know it's there, and we are accepting that it will give us recommendations. Maybe not all the best recommendations, but we are cognizant of that. And I think very open about what is being presented, but then but also understanding that we have to be transparent about it.
It's easy to disagree with a recommendation from an online shopping or a streaming service. I don't have to watch it. It is when algorithms make decisions for us that are really impactful, and part of being transparent, part of being fair, is that there's an avenue for redress. So what if I don't agree with that decision that ends up deciding on my mortgage or on a car loan or on some other impactful thing that I feel in my life more than accepting or not accepting a Netflix recommendation. So that is where we need transparency, and that's where we need fairness, and that means redress. In the same way that if a human loan officer says no to that mortgage, I want to know why too, and I have an avenue for redress.
And we're talking about things that are personal models of that affect an individual, but we also we should understand that this is community biased too, right? So the example I always use with people is that if I decide that an area has high crime, then I should police that area more, which means inevitably I will find even more crime, which means I should police that area even more. And I continue this feedback loop until I find myself turning areas that were moderately crime-filled into very, very high crime neighborhoods and communities. And so we should be conscious that that kind of thing is happening in the models that we're using, and work to break that, break those feedback loops, those negative feedback loops in the models that we have.
Yeah, it's an excellent point. And so AI, there's no magic. When you train something on data you already have, past is prologue. So whatever patterns are existing in the data, are baked into the data, are likely to survive in the predictions of the model you derive from it. So if you're training a hiring system on past hiring records of an organization, and you want to change the diversity pattern, why would you expect anything different than what has happened in the past? And we've seen those examples where these hiring systems then tend to, select on hire Jim, simply because of the frequency where that has happened in the past. And that's a very important part when we talk about bias and ethics. We need to agree on what we're aiming for. As a statistician, bias is actually the deviation, the average deviation between an estimate, a random quantity, and the target. There is a target. So if I were to train a natural language system on all the school textbooks of the last, let's say, 40 years. Would I be surprised if engineers would be predominantly identified as male? No. Okay, we don't want that. What do we want? What is the target? Is it a 50-50? Is it a random flip? But whatever it is, we have to decide this. And those are societal decisions that are things that we have to agree upon. And you cannot leave that to be the responsibility of the data scientists who work on the data. Right? Sometimes I think we ask too much of those teams to solve these thorny questions that need help from the larger community.
So with that in mind, how do we actually leap left in the development of AI and machine learning in the sense that we actually build ethics into the development of these models rather than evaluating them for biases after they're already created?
Well, I was thinking that to the extent that there are matters of public safety, we might need to consider, I hate to say it, but some form of enforceable governance. We're entering the era of self-driving cars. We have autonomous drones. We have camera surveillance systems, and all of these now use AI. And it's easy to see in these examples why governance is needed, because the risk and consequence of misuse, whether it's intentional or not, the consequences can be obvious. So, I'm familiar with government organizations like the Joint Artificial Intelligence Center. They can publish guidelines on ethical AI, but they're maybe contextually different than consumer-oriented ethics or medical AI ethics or population-based AI deployments. So it may be necessary, if it's not already part, and I don't know the answer to this, if it's already part of agencies like the FAA, the NTSB, or the FDA, to begin incorporating the testing and evaluation of AI efficacy as it relates to public safety and policy. And I don't actually know the answer to this, but does the NTSB test? They test the Tesla self-driving cars, but do they test the AI, or do they just count crash test dummies? I'm not sure. But then again, I don't own a Tesla either. So yeah, I should say. So I just this forum has caused me to wonder and think about what's the government's responsibility in public safety as it relates to this topic.
And I have seen a few seminars on testing some of the AI up with the NTSB, so it's on its way. So you should feel good about that.
I'll run out and buy my Tesla now.
Yes.
Well, the tricky thing here, it does beg the question. To have a government agency ensure that a model is not biased, people have to trust that the government agency is actually evaluating that in a fair and accurate way. But that's a big assumption, I think.
Yeah, I would agree.
I think we should let perfection get in the way of progress. I think
right.
if we're true to ourselves and we look at some of these decision systems that are out there that depend on human decisions, their expertise, their conscious, unconscious biases, and you were to compare that to a machine-built system, we might find out that we're actually doing better with an AI system. It's not perfection, but maybe it's an improvement. And so in the sense of continuous improvement, maybe that's a step in the right direction. Phil, you mentioned the autonomous driving. I'm always amazed how high the discussion, how high should the bar be set for us to accept an autonomous driving as being capable? When in turn we give driver's licenses to 16-year-olds who, by some measures, probably would not be as solid a driver as an autonomous vehicle in many situations, right? But our expectation of perfection or of excellence is much higher because we also don't have clear rules for accountability and responsibility. But I think it's food for thought for how stringent we need to be or we should be. I think the last mile in autonomous driving, these last percent, And to get from level 4 to level 5, autonomous driving, any condition without human intervention, it's going to be really, really, really hard. Really, really difficult. And I'm not sure when we're going to close that gap. But on the other hand, I'm buoyed by all the advances that we are now enjoying in our cars every day. The assisted driving technologies that are now present because we've pushed on autonomous driving for so long. So maybe we don't get to full autonomy, but on the way there, we get a lot of things that are improving, that are better, that are more helpful. And maybe machine learning, AI, can also serve in that role in improving things without being perfect. How do we bake it in? Let's start again with the data. This is the raw material. And I've been trained to think very, very carefully about what the data represent, where they come from, how they were collected. We had pretty strict delineation between observational data and experimental data, very careful design of experiments so that influences I can't control are randomized out. Where's that thinking now? Where's all that gone? Right now, there's just data. And the more I have of it, somehow the better it is. And I always ask, tell me what the data you work with represents. What demographic, what population, who does it apply to? And if you can't tell that basic question, how can you tell me whatever you do with the data will be applied to, is applicable to? If we can't answer that fundamental question, that should give us pause. But even if we do, if we have a good handle on the data we're working with and we know what it represents, then how do we understand what situations it should be applied to? Some of those failures we hear about with AI and machine learning and analytics is when things that are developed in good faith and in good methods and they were solid were applied in a completely different context. And who's responsible for that? That's inviting failure. And that's inviting problems. So you can introduce bias by the wrong application of something that's been perfectly well built and designed. So we also need guardrails around that.
And I think that gets to Michelle Callahan's question on the Q&A related to data quality and just how important it really is to kind of move upstream and ensure that you have good quality data that's applicable for the goals that you set forth for your project. And we're getting close to time here, so we've got 6 minutes left. Here's your challenge to finish this in 6 minutes. So one study reports that 93% of Generation Z, born from 1995 to 2010, will make their decision about where to work based on an organization's impact in society. So as Gen Z continues to enter the workforce, how do we harness this characteristic to perpetuate the idea of data science for good, context of AI systems where decisions have both rewards and penalties? Nice little softball question for you guys to go out on.
Hire Gen Z. Train them up.
You think that's it? Think you harness that by bringing them in?
I don't know. I don't know any Gen Zs.
We have a lot of them.
I hope that any generation is purpose-driven and mission-driven, and that we spend an awful lot of time of our lives at work, whether we're in an office over the last, 15 months at home. I hope that time is spent on really meaningful things, because otherwise, what a waste. So yeah. I'm always thinking about what is it that makes me get out of bed in the morning? And I have what Simon Sinek calls just cause. That's the thing that gets me going. It's improving lives through better decisions. And we all should have one. And hopefully you work for an organization that their mission and their just cause aligns with yours. Data for good is very, very important. I have many aspects. One is proving the benefits of data and analytics in applications and in situations where it's not being used. For example, using it to predict devastation or deforestation in rainforests. We can do this with data and analytics, and better than other tools. Let's use it. At SAS, we worked on using computer vision for detecting wildlife and for endangered species. These are great applications. Or optimizing a school system a busing system in an inner city to make sure that kids get to class on time. It's a wonderful applications of data and analytics. Why would you not want to be part of that? That's also creating a lot of value for society. And when I work with large enterprises, with customers, or whether they are private companies or public, they often want to know, what do you do to better the world? Not just, what is your product, but tell me how your product does good in the world. And I'm proud if I can then stand up and give examples of how it's not just drawing a bottom line somewhere, but helping make us a better society. So I hope it's not just Gen Zers asking this. I think we should all ask that. I ask myself that, we're driven by purpose and mission and trying to do good.
Yeah.
Do you think those applications are as applicable or as maybe widely publicized? Let me put it this way: are those applications as widely publicized, say, the next pop-up ad that we need, or the next recommender engine? Do we feel like we as a data science community are getting those opportunities out there and are telling people about all the good you can do with data science?
Yeah, I feel like I'm kind of biased in this conversation, working at Determined, right? Our whole.
Oh no, we've lost Alan for a second there. Alan, you should drive my house. The internet's working on this side of Blacksburg. Okay, so we may not hear from Alan, but it's 2:58 right now. We really do want to thank our keynote speaker and our panelists for their time, their insights, and we hope that those members of the audience are taking back these key ideas to their organizations. We hope they're taking them back to develop students, for those of you that are faculty. And we certainly look forward to our next seminar. And I see Tom Wojcicki coming on, so I'm going to turn it back over to him if he has any final comments or needs to let you know next seminar is coming up.
Well, thanks everyone on the panel, and Oliver, thank you. It's really stimulating and wide-ranging conversation you all had there. A bunch of ideas coming up. Thank you very much for participating in this inaugural event in the series. The next event in the series, for those of you who are still with us, will be on May the 25th, and it's going to feature the U.S. Government Accountability Office's Chief Scientist and Director of the GAO Innovation Lab, a gentleman named Taka Ariga. I can tell you from talking to him on several occasions, it'll be a very interesting talk, real animated as this one was today. Registration open now, and I hope to see you there. Thank you for attending today's virtual event. You can stay and network with fellow attendees in the social lounge, and I'll be hanging around there for a while, and I hope some of the speakers will as well. So join us in the lounge. Thanks to the speakers.
Thank you for having me.
Very much.
A privilege.
Thank you very much.
Thank you.